All right, section 1.3, exploring real numbers. All right, so there are different categories here. So I'm going to update my goal chart, but your goal for today, you ready?
Oh, yeah.
Is 1, to classify numbers. Numbers fall into different categories, okay? And then second thing you're going to be able to do today by end of the hour, hopefully, is to compare numbers. Those are your two goals. Let's do this. Let's create a table or like a box, and we're going to categorize different types of numbers inside the box. All right, so this whole box is going to represent real numbers. All numbers on a number line. So every single number on a number line is called a real number. Okay? When you get to Algebra 2, you'll learn that there are what's called imaginary numbers. Okay?
Is that like the point number? Like 1.1?
No. Those are still real numbers. Okay? Now, in this category, most of the numbers, well, I'm not going to say most of the numbers, are rational numbers.
You need to make this chart.
Yep. And then, if it's not rational, it's called irrational. So you got two types. So all numbers in here are called rational numbers. And over here is called irrational.
Does the box have to be big?
About this big.
But it's hard to say because you're like not
Okay. Yeah. Alright, so then rational numbers, inside the rational numbers, I'm going to draw another box. Inside that box, we have numbers
The box is too small.
that are integers.
Remake it then.
Okay? We have integers in there. So integers are rational numbers, okay? And also considered real numbers, which is all falls under this box, okay? And then inside the integers, we have whole numbers. Okay? Whole numbers. So if you notice, whole numbers are integers also, which are also rational numbers. So whole numbers are also rational numbers. Okay? And then inside whole numbers, we have what's called natural.
Is that it? Are we done?
That is it.
Okay.
Yeah. We have natural numbers. Are you ready?
And another box.
Okay. So now let me give you examples.
Natural?
We have natural numbers.
Is it irrational, like 3, 3, 3, 3?
No. I'll explain. Okay? So natural number, let's start with natural, which can be under the whole number, which is also an integer, which is also a rational number. Okay? So natural numbers, but not all whole numbers are natural, or not all integers are natural. Natural numbers are your counting numbers. So when you guys count, where do you start when you count? You start at 1, right? So the natural numbers, 1, 2, 3, dot, dot, dot.
So on and on.
Those are your natural numbers. Okay? It keeps going forever. Okay? Now, whole numbers. Whole numbers include 0. Okay? and it goes 1, 2, 3, dot, dot, dot. Okay?
Wait, so
So whole numbers have
The
no
difference
natural
between
numbers.
whole numbers and natural is that natural does not include
it
0.
has a 0 to whole number.
Yes. Okay? But
And then if it's just like 1
this is all. This can be also called whole numbers.
There's no 0.
So then what's the difference?
Okay? But if I say what kind of numbers is 0, then you would say it's a whole number, not a natural. But any other numbers like this is also a natural number. Okay?
Whole and natural.
Whole and natural, exactly. Okay? Now, here we go. Integers. Ready? Dot, dot, dot. -3, -2, -1, 0, 1, 2, dot, dot, dot. So these are positive and negative, right? Whole numbers. Okay? What's not in this? Can somebody tell me what's not in this? Say it again. Who said decimals? Decimals and what else? What's not in this? Fractions. Okay? Fractions and decimals are not integers. Whole numbers are natural. Okay? We're talking about in this, it's just whole numbers. Positive and negative. Okay? Now let's go to rational. So if these don't include fractions and decimals, rational numbers are numbers that can be written as fractions. That means you should be able to write it like this. Any number that can be written as a fraction is called rational numbers. Okay? That's rational. So if rational numbers are numbers that can be written as fraction, what do you think irrational is?
Numbers that can't.
Yeah. Irrational are numbers that cannot be written as fractions. Okay? So let me give you some examples. Rational. Besides being all these whole numbers and integers, I can say 0.3 repeating. That is a rational. Do you know why? Anybody know what 0.3 repeating is? Yes?
What is 3/9?
3/9 is 1/3, which is 0.3 repeating. 0.3 repeating is same as 1/3, so that could be turned into a fraction. So this is 1/3. So yes, 0.3 repeating is a rational number. Okay? What about 0.6 repeating? Yeah, what is 0.6 as a fraction?
3/6.
Not 1/3. 1/3 is 0.3. No. Oh, well, you know what? 6/9 you said? Yeah. Yeah, which is 2/3.
Yeah.
Which is 2/3. So that's that. And how about if I said 0.25? 1/4. So is that a rational number? Yes, it is. How about if I said 2.5? 2.5, or if I make it improper,
5/2.
5/2. So that is also rational. Okay? So any number that could be turned into a fraction are rational numbers. So can somebody tell me, how can I turn these into a fraction? 2/1, right? Or -3/1. Those are all, that's why it's called rational numbers. Everybody understand? Okay. All right. So anything repeating, anything that stops in decimals are rational. So over here in this category, irrational is decimals that do not repeat and that do not stop. Okay? So an example would be, what is that? pi. That's irrational. It goes on forever and never repeats. If it repeated, then it would be rational and you could turn it into a fraction. This does not. Okay? How about square root of 2? Square root of 2 is irrational.
See that lightning?
Yeah.
There's lightning outside.
Oh, wow.
Hey, sweet, old football. Freaking football.
Pay attention, please. Excuse me.
Hey, listen up. She's not done teaching.
You ready?
Thanks, Lawson.
What's square root of 1? What's the square root of 1? 1. Does everybody understand square root?
It's by itself.
It means what was multiplied by itself twice to get to 1. 1 squared is 1, so square root of 1 is 1. What's the square root of 4? 2. Right? This is 2. So these two are rational numbers. Square root of 2 is somewhere between 1 and 4. I mean 1 and 2, because square root of 2 is between square root of 1 and square root of 4. So this number is somewhere between here. This is about 1.4, and it goes on, never repeats, but it goes on forever. That's why this is an irrational number. Okay? Square root. So what about square root of 3? Rational or irrational? Irrational. Okay? So what about square root of 25? Is that irrational or rational? Rational, right? What's the square root of 25? 5. So if you could take a square root and get a number, right? Rational. And it's also besides rational, what else? Whole number, what else? Integer and natural. Yep. Okay? So that's how you classify numbers, right here. All right? All right, now let's go into comparing. I heard that a lot of you guys have trouble with fractions. Is that true?
No.
No? Depends. All right, let's go into inequality. Ready? Inequality. The word inequality means not equal. There are several inequalities. Are you ready?
Yeah.
That symbol is greater than. Okay? And then you have greater than or equal to. And then you have less than. And then you have less than or equal to. The way to read, most of the time, I'm gonna tell you later on, when you read this symbol, always read it from the variable side. Please stop. If the variable's here, this is greater than. If the variable's on this side, when you read it from the variable side, you read it as less than, even though symbol goes like this. Okay? When we're solving inequalities, you are going to be solving for x. You always read it from the variable side. So remember, the pointy end is the less than, and the open mouth is the greater than side. Okay? Any questions about inequalities? Okay, so now we're going to compare numbers. On a number line, farther away from 0 to the right is bigger. Okay? Farther away to the left is less. So negative numbers, the bigger the negative it is, the farther away it is from 0, the smaller the value. So bigger the negative, smaller the value. Okay? So let me give you an example. All right, let's do this. Oh, I wanted you to write from least to greatest. Ready? So you tell me. I have 3/4, -7/12, and -5/8. Out of these, which one's the smallest?
Or no.
Caleb?
5/8.
5/8? How can you be sure?
Wait, hold on.
17.
Why?
Because it's the most left of the number left.
How do you know?
The G.
Which one's, what is?
What will be the easiest thing to do to compare these three? Yes, ma'am. Thank you. Let's find a common denominator. So, look, what's the common denominator between 4, 12, and 8?
24.
24. So we're going to do 24, 24, 24, right? And they're all negatives, right? All right. What times 4 gives me 24? 6. So we're going to multiply top and bottom by 6, so this is 18. So that's -18/24. All right. What do I need to multiply that by? Millie? 2. So multiply that by 2, that's 14. What do I need to multiply 8 by?
3.
3. So 3 times 5 is 15. So out of these, which one is the smallest value?
14.
Right here, this is the smallest.
Oh.
Bigger than negative. And then what? And then the 15. So this is the smallest. And then it's this one. And then it's this one. That's how you know for sure. You need a common denominator. Okay? Everybody understand? Okay.
So much.
Huh? What was your comment?
No, it was just nothing.
He said he's
Hate about
gonna use
that.
this so much in his life.
Oh, yeah, of course he is. I know.
Every day.
Yeah, you use math.
All right, here we go.
No.
Opposites.
You do.
Can somebody tell me what the word opposites mean?
Opposites, they're different from each other.
Opposites.
They're different from each other.
How are they different?
One's two.
No?
One's negative one.
All right, ready? Opposites are numbers that are equal distance away from 0, but on the opposite side. Do you need to stop talking? So 1 and -1, they're opposites. Okay? 2 and -2, they're opposites. -5 and 5 are opposites. So when you add the opposites together, what should you get? 0. Okay? So make sure to check to see if their numbers are opposites. You add them together and see if you get a 0. Okay? So numbers that are opposite side of 0 on a number line, that's equal distance away. All right, so then can somebody tell me, what does this word mean, absolute value? What's another word for absolute value? Yes,
Doesn't it mean like if it's -1, it just changes to 1?
But
That's
why?
absolute value. That's
anybody?
that is what it does, right?
Then if it's absolute value of 1, does it become -1?
No. Because 1's the absolute value.
Nick? Another word for absolute value means distance. How far is that number distance from 0? That's what that absolute value means. So it's a distance. So on a number line, here's 0, right? And if I said, remember, absolute value symbol looks like this. That up and down symbol. This is the absolute value of x. So if I said, okay, what is this? If I give you this as a problem, it's asking you a question. It's asking you, how far is 5 away from 0? So on a number line, 1, 2, 3, 4, 5, it's asking you, this is a question. So when I ask you what this is, what should you say? 5. Should I keep this? No, then you're asking a question back, okay? The absolute value symbol goes away, and this is saying, this is a question saying, how far is 5 away from 0? And your answer is just 5. So same thing with negative 5. It's asking you, how far is negative 5 away from 0? So it's also 5, because I'm going to go this way, right? Here's negative 5. These symbols right here, they come from construction or architects that draw floor plans. These symbols in their plan, if they want to show distance of something, they use those symbols and they said it's 5. Okay? That's where those symbols come from, absolute value symbols, because it's a symbol for distance. So then if I were to do a distance from here to here, I would do this, my arrow, and then put 5 there. Yes?
So the answers to the absolute value will always be positive?
Yes. Because remember, distance can't be negative. Distance is always positive. Okay? So whatever's on the inside, it's always positive. So what would be this?
Positive 1.25.
Thank you. It's positive 1.25. It is 1.25 units away from 0. Okay? Any questions with absolute value? Go ahead. No? Any questions? Okay. All right.